Okay, this is a no-load test of the new circuit board for the dew heater running off a PIC 16F88. It's a dual channel or single channel depending on how you want it configured. And when I power it up, I'll show you how that part works about the configuration. So when I juice it up, you'll notice the two red LEDs blink in unison. That's in single pot mode. So what I'm able to do then is in unison by one pot control the duration of the pulse and the width, which is about 5 seconds total. So these are a fraction of that. It's broken up into 253 parts. I left the bottom to make sure I can actually turn it off where it's really off. If I want to go into dual pot mode, in this case I'm going to take the jumper, like the same like you could have for a PC jumper, put it over here, put it across the two pins on this side. Now when I bring it up, you'll see the red LEDs blink opposing each other, and that lets you know you're in dual pot mode. So what's happening is this pot controls this side, so if I shorten it up, maybe too short, it's off, there we go. So you can see that's a fairly short period. The other pot's set longer, set it really long, so now at the maximum length on it, which I'll do right now, you'll just barely be able to see it flicker at the end of the 5 seconds. There's the blink. That was more for debugging, but I just left it because I like the effect. There's a yellow LED here also. We're going to check that next, and that controls the letting us know the battery status. When the battery drops below about 11 volts, that will come on. When it drops below 10 volts, it'll start blinking and it'll cut off power to the dew heaters to help save your battery. So that'll be our test now. So I'm going to come over here. We're going to, everything stays the way we would expect it to. When we get down to 11, boom. Now the light is on. We still have power to the dew heaters. Everything's chugging along there. So we bring it down a little lower. Now we're at the 10 volt mark. We have a blinking yellow light. That yellow light is controlled with pulse width modulation built inside the PIC, so I can control the brightness through software. And you'll notice though the red LEDs, which are tied right to the 12 volt power that goes to the dew heaters, are not coming on at all. Now if we were to come up here and go up a little bit, now we're above 10 volts, so what's happening is we're back to a solid yellow light and the dew heaters are functioning again. If we come back up, actually I had to go a little higher, but 11.2 coming back, then we're back to normal. And if I come back here to 11 again, we come back on. Alright, as far as the red LEDs, they are controlled entirely just by a resistor tied to the 12 volt, so they'll dim a little bit as the voltage for the battery drops, but that seemed okay. We do have a RUEF 400 in here to act which is a resettable fuse, and about the 8 amp mark it'll heat up and separate and cause the circuit to break completely. When it cools back, it'll come back on. Also, I would recommend having a fuse built into the plug that goes into your 12 volt. I have one set at 10, and that's kind of, if all else fails, that definitely should stop things. The next test we'll be doing down the road, once I get it in the box, we have this nice little box here. If all goes well, we'll have some RCA jacks hooked up to it and hook it up to some dew heaters and watch what happens when we run some real power through this thing. Speaking of that, at the moment we're only drawing 2 milliamps or 3 milliamps, depending I guess if the LEDs are kicking in or not. And so really this thing could run for a very long time off a car battery.